What is up, most distinguished patrons? Today we are going to do a voiceover on a job that I did simply because, well, I couldn't film it while I was doing it, and I wasn't planning on releasing a video on this, but I thought the content was good enough, and you guys have been asking me about higher liability and frame repair jobs, so this is kind of going to be the ticket for that. So what I have for us today is a video that I'm going to talk about a frame repair that I did on an E450 van. Now the van pictured is not the actual one that I did this repair on, but it was very similar. So what you have is a van cabin chassis with a whole box setup that was built on it. Now this particular van was built by a company that's fairly well known for making high-end RVs and SWAT vehicles, and they actually produce, I believe, a vast majority of the Snap-on trucks here in Wisconsin and elsewhere. And I'm not going to name their name because, well, Googling would figure it out fast enough anyways. And I'm not here to trash talk anyone. I'm more about let's find a way to solve problems and do things right. And I don't see the point in trash talking them, but clearly you'll see via these pictures I'm going to share that some things went wrong. In particular, they had to extend the factory frame from the cabin chassis about maybe 5 foot back in order to catch the full length of the box. And their tie-in was absolutely terrible. It's kind of appalling that they would have let this out the door, and you'll see pictures of it shortly. How this problem you're going to see came to light was a guy was doing an oil change or an inspection on it and saw this frame tie-in, and he immediately went and got the boss and said, hey, we got to do something about it. And since I'm the welder in the shop, it was my job to come up with a solution to fix this. So let's start out by looking at what I'm talking about. So here we have where they tied into the factory frame rail end. And just by looking at this, we can see a couple problems. So the first one being that the bottom of the frame rail was never welded, so there's no tie-in there. And, well, the weld quality looks pretty poor, but this is a bad picture, so we can't really judge too much. But also up on the top part of the rail, we don't see any weld either. And again, we'll see some better pictures of it. But this is highly suspect and not something you want to see under a vehicle that probably cost $150,000 and is basically new, aka just out of warranty new. So this is the opposite side of what we just saw, and you can see pretty poor scabby looking welds, a pretty poor fish plate. You can't tell because that wiring harness is in the way, but the bottom was never welded, and the top really wasn't welded either. It had a spot weld on the top of it, so the only thing supporting that frame is that fish plate, which, by the way, I think was about 1/16 thick, and that frame rail's 1/4 inch. So that fish plate is the equivalent of like auto body thickness almost on that. So I don't know what it's doing. Who knows if there's weld behind that plate? I doubt it. I think that they just slapped that on there after welding the other side with a poor looking weld. We'll see that in a minute as well. But I don't like what I see. And I'll be honest, guys, this is a deal. I don't make fun of anyone with their welds, and I've done far worse than this, but I'll be honest, I've never done a weld this bad on a frame. And if this is where you're at for skill, you probably shouldn't be welding frames together. At least that's the way I see it. But realistically, we got some issues here, and I'll show you some more pictures so you can kind of grasp the whole totality of the circumstances that I'm dealing with here. So here's the top part of that same frame rail, and you can see there's no weld there. The top of it had a spot weld on it, and what you see that kind of might look like a weld overhang, that's just the fact that their tie-in piece isn't as wide as a factory frame. But zero penetration on that tack weld that's on the top there, so that's definitely not good. Now there's a ton of wiring that passes through that gap between the side rail and the interconnecting piece to the other side. So this side kind of required a different method to do a repair patch to strengthen it than the other side. The access to the other side was also pretty bad because the drop-down aluminum box that was part of the bed system couldn't be moved, and there was no room to weld it or re-weld it or put a fish plate on it. You'll see as the pictures progress. So here's a better lit version of the opposite side. So this is kind of like the first picture that we saw, and clearly you can see no weld on the top rail, no weld on the bottom of it, and just flat out scabby welds. Sheet metal for a fish plate. Again, not what you want to see on something like this. Here's the underside of the same picture that we just saw. And no, that isn't weld in there. That's just underbody coating. But again, no tie in there. And you can see that box that's hanging down below the frame that gives zero access to the side of the frame there, which really kind of sucked for trying to do a repair on this. And the weld, which I didn't get a picture in there because it's simply too tight to get a picture, but it was terrible. Probably one of the worst welds I've ever seen on a frame in my life. Here is the somewhat accessible side frame rail, and you can see it looks like they ran vertical down. Hard to tell really, but vertical down has virtually no penetration, and you generally don't want to do that on 1/4 inch for a frame. You can see that their fish plate, for some reason, they decided to weld one side of it and not the other, so that's kind of awesome. I don't know what they're really achieving there. But this whole job that they did is pretty sad, to be honest, and it wouldn't take that much work at the start to have done a better job. And I didn't get a picture of it because I was kind of in a hurry to do this job because I knew it was going to take me some time. But the back frame rail was like torch cut where it hit the back of the van, like where the bumper you step up on, and just hacked together. And it just, stuff like this makes me feel just upset because companies are building crap like this, putting it on the road and selling it to municipalities for hundreds of thousands of dollars, and they can't even be bothered to do a better job. And let's face it, this is just one section of the frame. Imagine what else on this thing is hacked up or just done poorly. Not something I would want to trust on a highway. So let's look at how I repaired this. So I will show you all of my work and talk about what I did and didn't do. But first I got to give you guys a disclaimer, and it is as follows. One, I'm not a certified frame welder. In most cases, there is no such thing here in the United States, and clearly you don't have to be a certified frame welder to build these vehicles in the first place, nor do those welds get inspected and have to meet any kind of standard apparently, because how would this particular truck exist in the wild with these terrible welds? I don't know, and it comes down to simply there's no inspection process. Two, the frame being welded could be high strength steel. Now in this case I doubt it is, but a lot of newer trucks are being put out there with higher strength alloys that are heat treated after welding. If you go and weld on them and don't heat treat it after you weld, which is obviously going to be an impossibility for you to do at home, you will have brittle welds that will likely fail in the heat affected zone. Like say with chromoly tubing, often fails not on the weld, but in the heat affected zone unless you reheat treat it, which again, nobody does it. So when you do frame repairs and you just willy-nilly weld on something like that, you could set yourself up for failure. Now in this case, somebody already botched together some steel and welded it to the factory frame, and anything that I do will likely be better than what they had, so I have that on my side. Number three, my work and I myself am backed by a multi-million-dollar insurance policy to where I would never really be held liable if a repair that I did failed, causing death, destruction. You get the picture, the lawyers speak, right? You probably don't have that. To put it in perspective, general welding insurance is $500 a month, and that doesn't include frame repair. I can't imagine, if that's what your job centers around, how much that insurance probably is. $1,500, $1,200 a month. So you may want to take a pass on a repair job like this at home simply because of the liability that's involved. And lastly, the way that I did this repair is not necessarily what I think is the right way to do it. The right way would have been to remove the body, grind out the welds, and do a proper tie-in, fully fused, clean welds, etc. You get the picture. I simply was unable to do that. I do believe that my repair will both last and be much stronger than what it was, But I'm not an engineer, nor are you probably. And just, again, willy-nilly welding plates onto something thinking it's going to be better can create a nightmare of problems and failures down the road because you didn't think of something. A great example of this would be certain frame members are designed to flex, and if you make them overly stiff, what'll happen is it'll break somewhere else in the frame where it wasn't designed to bend, and it'll break there. So again, if you're not an engineer and you're in over your head and you don't have the welding skill, you probably should avoid a job like that. Now, enough of the lawyers speak. Let's go in and look at what I did. So this whole job I ended up TIG welding. That's not normally what I would do because TIG requires exceptionally clean steel. Luckily, this was new enough that the rust bug hadn't destroyed the frame. If it was, any older than what it was, it would have been an impossibility to TIG weld it due to the poor surface and the material itself. So I lucked out in that respect. But TIG isn't the first choice either because it's extremely slow, can't really handle contaminants, and it's not really that easy to weld with TIG in tight spaces, generally speaking. But it did work in this case. And I chose it for two reasons, really. One, because this thing sat so low to the ground and I couldn't lift it up because the lift was broke, I basically would have been eating sparks from MIG or stick, and I just didn't want to deal with that, okay, because it sucks. And the second reason was something I didn't realize at the start was there was some kind of a weird black undercoating on everything underneath this, and I tried to do like a 1-inch MIG weld on this, and once my hood went from darkened to light state, I realized that about 1.5 feet section of the top of the frame rail was literally on fire, and I ended up like hitting it with my glove, and it took like a fair amount to put it out. And I don't know what that crap was, but it was so flammable that just welding sparks and the heat from the backside of the weld through the steel was enough to set a significant amount of it on fire. So based on the totality of the circumstances, TIG just seemed to be the solution I was looking for. So the start of the repair, that area on the bottom of the frame rail, I put a piece of steel in there, fully welded the left side of it that you see in the picture as well as on top of it to tie all of that in together. Now there would have been a lot of ways that I could have done this better, I guess, but it's welded good enough, especially on the top and the sides. I'm not really too worried about it, and I don't think it's going to crack here. That circle too that wasn't welded or anything, I plug welded that fully flush as well to tie into that plate that's on top. And that plate actually went back a little bit further than what you see there. It's about 3 to 4 inches long. Obviously, I couldn't go past that cross member there any further forward, and that's riveted on there. Speaking of that, anytime you see rivets on a frame or anything instead of welds, ask yourself why it's riveted. Oftentimes things are riveted, like you look at semi truck frames and stuff, they rivet it because it's heat treated steel. So welding next to rivet, you might think you're being smart by welding it, but you might actually be the dumb bastard that's welding on high strength steel and not realizing it. I ended up grinding that whole weld down that was original, and then there was a significant amount of undercut on both sides of it, so I ended up filling that in with TIG. Now, I know you're saying to yourself, Jesus, that's an ugly looking TIG weld, and you would be right. What you got to understand is when you try and fuse together undercut and weld defects like that, this is 1/4 inch plate. You have to run enough amperage to where you know something is melting. And TIG has very little penetration as it is. So I was up around 180, maybe 200 amps, running it as hot as I could to try and get some kind of internal fusion in there to where I know that the stuff is fused together. And to get a better looking weld with TIG in such a circumstance, you'd really need a bigger gas cup like a number 12. I was running a number 7, and when you lose gas coverage, your weld grays out, and it also doesn't flow out as well. But again, it's kind of just a circumstance. Now, this TIG weld, I ground down flush and polished the whole frame with a flap disc putting a lot of emphasis on not grinding into the material more than I had to, because this is 1/4 inch thick steel, but you don't want a ton of base metal reduction by grinding it down to where you might have 3/16 or less thickness, because guess what? You just made it weaker. Now again, heat is not really your friend when it comes to frame repairs. You don't want to be pouring shit tons of heat into that and thinking that somehow you're going to make it stronger. So I took care of the undercut, ground it off, and now it's ready to be fish plated. Here's a multiple pass weld on the bottom, and I stopped with the 2 cap passes basically right at the corner. Don't be in the habit of doing that. I should have ran it up around the corner and then ground it down. I believe my first pass I did, but hey, I didn't on those, and I'm going to call out bullshit when I see it. So anyways, now that this is all done, I'm going to end up grinding it flat like I said and throwing a fish plate. So let's look at that fish plate. So here's a fish plate that I came up with. It's made out of 1/4 inch thick steel, which is the same thickness that the factory frame was. Now, I'm not an engineer. I don't know that much about structural repairs. I don't like doing square or rectangle fish plates because what I've seen is the corners tend to crack off if it's stressed. By doing more of a oval or a soft corner, I've noticed that welds seem to fail less. And if you look at any kind of heavy equipment, generally speaking, they don't have hard corners on stuff they weld, like skid steers and front end loaders. Their plates more or less look like this, so I kind of follow after that frame of thought, I guess. Now I did a 2-pass TIG weld on this. So I did a root pass all the way around, and then I did a weave cover pass. Realistically, that single pass is likely strong enough and would have no issue. I just decided to do a little bit better of a job and put that cap pass on there and weave it to get it done a little bit faster. Now, is this the solution that's best for your job or what you need to do? Who knows? You got to do your own due diligence and apply what I did to your situation to determine if it's the right thing to do. Like I said earlier in the video, good luck trying to TIG weld any kind of old frame from the 90s, 80s, whatever, and think it's going to work. There's so much bad, crusty material embedded in that frame that you're never going to get clean welds. This worked for me, and it didn't light that frame coating on fire, which is a huge benefit because I don't know how I would have put it out fast enough. I got lucky that it didn't get out of control faster than it did, so be smart about this crap. And by the way, you should probably pull a gas tank out if you're welding near it. And on that note, I forgot to mention another reason I TIG welded this is because about 7 inches away is a gasoline tank for this. This isn't a diesel vehicle. If it was diesel, I'd be less afraid of lighting the tank on fire. But a plastic gasoline tank was 6 inches at most away from these welds. So again, MIG welding it or stick welding it with super flammable crap on the frame, not too smart. All right, let's look at the cap pass I did on this. So this is mostly done. The whole top is done. You can't see the bottom. You'll see it in other pictures. I just got the left side of that to do. Not my best work by any stretch of the imagination. And I'll tell you what, sitting on my back with my face about 3 feet from what I was welding taught me one thing. I need better contacts or glasses because I couldn't hardly see shit. And I'll be honest, I hate doing vehicle repairs on like exhaust and frames and all that because the access is so limiting that you can never get the angle you want. You can't see what you need to see, which by the way, I was using a Lincoln face mask to weld this because my head wouldn't fit with my normal welding hood. And it's just everything about it is harder than it should be. But that's the reality of most welding in the real world, is that it's not on a bench with perfect access, great visibility, and all of that. The reality is most repairs will never be that. So the better you are when you have access, the better you're going to be when you don't. So here's the bottom. I put a final cap weave over everything to tie the fish plate into the bottom, as well as to just add a bit more reinforcement. Now that hole there that you see, I ended up fully welding that out. I don't have a picture of it, but I did after this was shot. Here's another angle of that. You can see everything's pretty well tied in. No real undercut, underfill. The job went pretty good on this. And you can also see all of that wiring harness. There's fuel lines and all that underbody coating on all that crap as well. So this is looking pretty good. And here's a straight on shot. Overall, the repair on this side went pretty good. It was pretty time consuming. I would have liked to have gotten it done faster, but again, the limitations of using TIG and not stick or MIG really slowed the progress down. But at least I can rest assured and sleep well at night knowing that the weld is about as good as you can get given the circumstances. I mean, don't get me wrong, I'm okay with MIG and I'm actually better at stick than MIG, but I really feel confident that that's not going to break or fail. So now let's look at the other side. Now I didn't mention it, but on the side we were just looking at, I did grind the top and the bottom and weld that. I just didn't get a picture because it was impossible to get a camera in there, to be honest, and do that. Now this side you can see I ground the top and I TIG welded it all the way up. Same thing with the bottom. I did the bottom just like the other side. Now this side, the back side of what you're looking at was inaccessible because of the box of the van body. So I didn't have the option of fish plating it on the opposite side. Ideally, you would have to remove the box, which I can't even imagine the nightmare of wiring you'd have to disconnect to even attempt that. So what I ended up doing was tying in the top and bottom rails together where they didn't weld them. And then I put a plate offset into the C channel that was about a 1/4 inch inset from the edge of that C. And I welded it on the top and the bottom. Not the ideal circumstance or choice. I would have really liked to fish plate it just like the other side, but there just wasn't an option and I needed to do something to prevent this frame from breaking. Down the road, it might prove to be an issue. It's hard to say. I don't think for the use of the van, being that it drives at low speeds, doesn't see much highway use, and will likely last 15 to 20 years with probably 500 miles a year on it because it mainly sits. I think it'll be okay and it'll be better than what it was. Now, unfortunately, I either didn't take pictures or they were lost. I don't know. I can't seem to find them, but just picture a rectangle plate put in to that C slightly inset and then welded to strengthen that. And like I said, I did grind down all of the welds inside of that frame and re-welded over them with TIG and in an effort to make it stronger because, well, their welds had undercut, lack of fusion, etc. So at least it's somewhat better than it was. Now, the side that I didn't get a picture of because the box blocked the view, that weld is bad and there's nothing I can do about it. Again, I'd have to lift the box to grind it down and repair it. But it is what it is, guys. Sometimes you can't make perfect repairs, and this is a great example of it. All right, let's go to conclusion. So what did we learn today? Well, I learned that welding with poor access under a vehicle on your back really sucks, and my knees and my back still probably aren't quite right from this, and I did this job, I don't know, a month or two ago. But seriously though, it's very difficult in poor access places to get solid welds down. Whoever welded this to begin with probably was under a time crunch and their boss probably wrote them to get it done as fast as possible, get it out the door. And I don't like that kind of production level, like especially when you start talking, as much as $250,000 for something. Should take better pride in your work, and nothing like what you saw today should have ever left the shop, especially for a municipality. I mean, granted, it was just a bookmobile, but come on, man. If they're doing this kind of stuff on a bookmobile, I know they're doing it on SWAT vans and police vehicles, and your Snap-on truck pretty soon will probably break in half if they're doing this kind of BS on that. But seriously, though, just take a little bit of pride in your work And honestly, if you can't put down at least halfway decent welds, you should probably not take a job like this. If you can and you're pretty confident and you're willing to put in the time to prep the material, then give it a shot. Keep in mind about all the liabilities with a job like this, and also keep in mind that the way that I did it that you saw in this video might not be the best way to do it. It isn't a perfect solution. I even mentioned numerous mistakes that I made and things I would have liked to have done better. You can always do better, but this is how I did it, not necessarily how it should be done. So take it for what it is, gentlemen. Until next time.